Hello, everyone, and welcome to this episode of Cloud Currents. I'm Dave McKenney, and with me today, I've got Yan Cui. How you doing today, Yan?
Hey, David. Yeah, thank you for having me here.
Great. So I'm excited because the topic today is about serverless, and it's an area that I just, quite frankly, don't work with a lot as of yet. And so I know I'm going to learn a lot. Hopefully, I'll sound like I know a lot, but this is why you're here. So before we get into the trenches about serverless, let's talk a bit about how you got here. So one of the few things I am aware of is that serverless really hasn't been around mainstream-wise for all that long. So I'm assuming you probably didn't get started right away with it. Maybe you didn't study it outright, but tell us a little bit about your career leading up, maybe the early days leading up to serverless and how you got into it.
Yeah, sure. I mean, I guess my first professional job was working in the investment banking, actually. I was working for Credit Suisse back when the reputation was still intact. So I was working with on-premises stuff, and me and my team, we used to plan for months ahead of time for when we're going to get a new server into our rack, and what wonderful things we're going to install on that server. And then 2009, I got a job working in the gaming. So, back when everyone was playing games on Facebook. So I joined this games company, building Facebook games. And that's when I first got into the cloud with AWS. And so I went from spending months planning for a new server to just clicking a button, set up auto scaling, and suddenly 5 minutes later, I've got a new server running with my, with whatever stuff that I've got deployed. And then, so that was a big game changer for me. And gradually, 2014, you've got the containers came out. And so I was playing around with the containers for a bit. That made things a lot even easier in terms of having the consistent configuration for your execution environment, for your code. So deployment and a lot of things becomes a lot easier, more manageable, more repeatable. And then I guess 2014, that's when they announced the Lambda. With Lambda, at the time, when they first announced it, it was fairly limited. It was just, okay, you drop a file into S3, you can trigger this Lambda function thing to do some processing. There's not a lot you could do back then. And then they added support for Kinesis as well with Lambda. So you can do some real-time data streaming and the processing. It was really 2015 reInvent. They really opened the floodgate with the integration between API Gateway and the Lambda. So you can actually build entire REST API using API Gateway and Lambda, both of which are considered the serverless components. And I guess the phrase serverless really was still quite early in those days. People were just starting to come up with a name for this new paradigm where you don't think about managing servers and configuring them and configuring scaling groups and things like that. So nowadays, I guess when you talk about serverless, we are really talking about any number of technologies where you don't have to manage the underlying infrastructure. And ideally, you only pay for them when you actually use them. So you're not paying for resources that are sitting there not doing anything. So, with API Gateway and Lambda and DynamoDB and lots of services like that, including S3, we can all call them serverless because we only pay for request for when we actually use those resources to do something, as opposed to paying for uptime by the hour, even if nothing is actually running. So I guess in terms of how long it's been around, it's probably been around, at least Lambda has been around as long as containers has, but it's probably just hasn't had the same mainstream adoption as containers. But having said that, there's been a lot of companies who's been on the whole serverless scene for a long time. People like iRobot and people like Basel and a few other companies has been pretty serverless first from very early on. And myself, I've been involved with the serverless. I guess I got into serverless around 2016. And that was, and ever since then, I've been pretty much focused on the serverless space because, for me, even though when I went to the cloud from on-premises stuff, I was still spending about 60, 70% of my time just setting up and dealing with infrastructure, there's a lot of things you got to configure: the networking, patching the machine images, and configuring and updating scaling groups, thresholds, and installing agents on the boxes. And there's just still lots of things that you got to do. And so when Lambda becomes something that's more feasible, I can use it to build entire applications, and I can just focus more on what my code should do and what my customers want, as opposed to thinking about infrastructure. It was, it became a no-brainer. And nowadays I can build entire applications on my own, fraction of the time and cost compared to what it used to take a whole team to do, just a few years ago. So, serverless for me has been a massive game changer for me, both personally but also professionally.
Yeah. So I'm not going to look past the fact that, and I want to ask you a bunch of questions about how you made the transition from the financial industry to gaming. That's fantastic. Probably a much different level of stress. But so it sounds like you started shortly after Lambda hit the street. So 2016. So were there problems that you just that you noticed that things like Lambda could help solve, or did the technology just kind of speak to you in the sense that you mentioned how you were waiting for servers to arrive, you got into the cloud, you could just start spinning up things at will as you needed them, a lot less friction there. And seemingly serverless adds only to that, or that frictionless deployment, being able to just to work on your code, have it executed in some backend compute. So was it the technology that really grabbed you, or were there problems that you had that you said, all right, this is the answer. I'm going to go work on this now?
Yeah, I guess, once you've got more integrations within AWS for Lambda, at least that's when, I guess, 2016, that's when it really happened. I played around with Lambda back in 2015 as well, but back then a lot of the tooling just wasn't quite there in terms of deployment frameworks. There wasn't anyone that works particularly well out of the box, but also just in terms of use case. I mean, the power of this serverless compute really comes in what information can you send to it, and how easily you can integrate with other things within your AWS environment. So with working with containers and working with EC2, you still have this problem of, okay, yes, it's a lot easier compared to dealing with your own data centers and things like that. And it's a lot faster, more scalable, but there's still a lot of things you got to do. If you just think about the networking side of things alone, there's just so much to networking, and it takes almost a degree to just understand how all the different networking controls you have to deal with within AWS. And then there's also trying to do any kind of reasonable security posture. There's just also a lot of things you got to do as well, from the virtual machine itself to your code, your dependencies. And when it comes to containers, the images that you base on, you still have to patch the machines that you run your container images on, depending on whether or not you're running ECS or Fargate. Obviously, Fargate is a fairly new thing, relatively. So there's a lot of people that was running containers. At least when I was doing a lot of the containers stuff, was you're building on top of one level of infrastructure, and then you're going to build on top of that, but you still have to manage the EC2 instances under the hood, which means that there's still a lot of things you got to worry about and deal with. And when you are working in a relatively small company where you can't just make it somebody else's problem, that means as a feature developer, I have to work on everything the business wants, and then everything else that we need in terms of actually having something to run our code, which nobody really cares until it goes wrong. It's one of those things me and my buddies always talk about, how as a backend developers, you never get no one ever pats you on the back, say job well done when you're working. When you only ever hear from people when something's not working. And
that's right, the dilemma.
Yeah, infrastructure is kind of like that, where you kind of just expect them to always work, except when they don't. So the kind of problem that things that Lambda really solves is just taking care of all of that scaling, having that good redundancy and resiliency out of the box. with when I was working with EC2, I have another thing you often have to do is before you launch a new game or product, you have to do this capacity planning, work out how many requests per second can we handle really roughly, and then you have to work out, okay, how many AZs do we need to have a presence in, and how much machines we need to have, what's the scaling threshold, how much headroom do we need to give ourselves so that when there's a spike of traffic, we're not going to see a huge degradation in performance because we are CPU saturated and whatnot. So there's still a lot of things you really have to think about, plan, and pay for even when the users don't come as you plan. And so with serverless and the pay-per-use pricing model and the built-in scalability, you just get a lot of that out of the box. You just don't have to think. There's just a lot less things you have to be responsible for and have to think about. And for small applications that don't have millions of users, you probably also find that your application is going to be a lot cheaper to operate and run because you only pay for the requests when they happen, as opposed to paying for uptime and having to pay for having multiple servers in every single availability zone, just so that if one AZ goes down, you don't lose the entire application. And the fact that the security is going to be a lot easier when you don't have to be responsible for the security of the operating system, which is a whole class of attack vector that's taken off the plate from your plate. And that's why, in fact, I think security is one of the reasons why a lot of the, financial companies, financial institutions like Capital One, FINRA, and many others have actually gone really big into serverless because they see that as a much easier way for them to meet all the security requirements that they have in the regulated requirements that they're in. Than to try to meet everything themselves and try to build all the infrastructures and manage all of that infrastructure themselves. So there's just so many different ways, so many reasons why I think serverless just makes our lives a lot easier and make you more productive as a developer and as a business.
Yeah, you've already answered another question that I had in the back of my head there about it plays into the security, but the whole attack surface comment and whether things are online sitting idle or only enacted when they're ready to either be executed. That's an interesting kind of paradigm to wrap our head around. So you mentioned a couple of times now we've been talking about Lambda and AWS. We know there's others like Microsoft and Google, but you're right. 2014 was when they announced it, and I remember being at reInvent when it was announced, and I was thinking in the audience, sitting there, and as they talked about Lambda, like trying to re-explain it to myself in my head. Like it was a great internal monologue. Trust me, it was fantastic. And the way I sort of dumbed it down, and maybe this is the way they even talked about it, was that, look, you're using containers. We're effectively allowing you just to take the code that you've written, and you no longer even have to manage the container or the backend compute. If you use these particular types of languages or frameworks, you can simply submit to have your code executed. And I remember thinking, man, I'm still trying to get containers all wrapped up. Did we even, at that time, we hadn't even really decided that Kubernetes kind of won. And so anyway, it was interesting to see that we've already made that leap. And I guess as a method of timelines here, we talk about how your virtual machines were the natural progression of bare metal, and then maybe even containers have been the natural progression of virtual machines. Is it right to say that serverless is a natural progression of containers, or really were they more of a fork in the road that happened at the same time? Because it seems like a container can do what serverless can do, but serverless is, like as you've pointed out, removing and abstracting a lot of that back-end compute. But do you think of the two as a progression of one or the other, or do you think of them as two separate technologies really altogether?
I consider them as two separate, two different parallel tracks, but interestingly, they're also kind of converging in a way, because if you look at things like a Google Cloud Run, it allows you to have triggers, have events trigger some compute tasks to be run in your container cluster. And equally, you have nowadays you have things like Fargate, which allows you to kind of run. They call it the serverless containers. Which is probably not my favorite way of describing it, but you also have, on the other hand, you have Lambda functions that are now able to allow you to, instead of uploading your code into like a zip file, you can deploy your code as a container image. Excuse me. So yeah, you can deploy your code to Lambda as a container image, and so it's able to load a container image from ECR, and you can have something that's up to 10 gigabytes instead of 250 meg in the zip file, and you're going to have potentially something that's with Lambda function that can be more long running as opposed to just the ephemeral only runs when there's a request. So I think eventually the two technologies might just converge in terms of what you can do, and you can have more ephemeral container environments, and then you can have a more long-running sort of service for Lambda functions that's not limited by. So right now you're limited by 15 minutes of execution time, but maybe they will relax that. And in terms of the concurrency model, right now with containers, you've got your application basically handles the concurrency in your application, whereas with Lambda, the concurrency is handled at the platform level, where Lambda functions would create all of this execution environments. Every single one of them is going to handle one concurrent request at a time. So essentially in your code, there's in your application, there's no concurrency. You're not handling concurrent requests. But there's also other fast or function as a service platforms that are based on containers, which do allow you to have concurrency in the process, so that your application can handle multiple requests at the same time, so that you get more efficiency in terms of cost, and also making use of those idle CPUs when you're making an IO call to some database or some other third-party API and you're waiting for a response. So Lambda may do something like that in the future as well, so that for customers who has a more high throughput environment where they don't want, they want to make more use of the Lambda execution environment and handle concurrency themselves, and potentially paying less for the Lambda functions. Then the two may even become closer and closer in terms of the use cases you have, and also what your, I guess, development story, experience may look like. So I do think there are two separate sort of developments or different paradigms, but certainly the technologies are converging in terms of, I guess, characteristics.
Yeah, that's interesting about the concurrency model, because I'm kind of thinking if I was to deploy something in serverless, I'm probably deploying something that's more expecting really just an input and output, like a state, if you will, where it's got a job to do, and it's that one job. If you're going to probably do it well, otherwise he'll just be back to the days of creating some very monolithic functions, which is probably what I would do. I would probably do it all wrong, probably put everything all in one function. But we've kind of danced around defining serverless as we talk about containers, what each one maybe does that the other one doesn't do. But if you had to summarize what we've talked about now, and maybe anything additionally, defining serverless to somebody, and using containers as examples, what would be your way of describing serverless to somebody who's new to it?
So if we think of containers as a way to abstract away the machine, then the serverless is a way for you to do away with the machine altogether and just think about your actual application. So instead of still having something that wraps around your application, that you deploy application to run something on top of something infrastructure, you just think about this application, and then that's it. You upload it to the cloud and tell the cloud, okay, run this when something happens. So I guess that's kind of the model I'm thinking in terms of describing it to a developer. But in terms of describing the technology itself and how to classify something as serverless, I tend to classify it as technologies that where you don't have to worry about provisioning and managing servers, and you don't have to worry about how the scaling is going to happen, and you only pay for the technology, the resources when they run. And so you focus on just your application and let the cloud deal with everything else, including the security, including the provisioning of the underlying infrastructure, as well as the scaling of those infrastructure pieces.
So do you find that most serverless platforms, are they, from a compute perspective, are they backed by container runtimes, or are they using any sort of bare metal or virtualization technology?
Yeah, so I mean, when you talk about Lambda functions or any other, so I guess functions as service type of things, they all kind of run on servers in the same way that ultimately we still need to have the machine that runs on servers. That's no secret. And I think every time I say serverless, someone always reminds me of that, which is
That's
true.
Pretty funny. Yeah,
yeah. I mean, which is true, but it's also kind of missing the point because so is Wi-Fi. Wi-Fi has got wires. I mean, that's the wires going to a cable, going to a router somewhere. Just that when you're using those Wi-Fi connections, you don't think about those wires because it's not your problem, right? And when it comes to serverless or specifically functions as service, I think Microsoft Azure functions are running on containers. They actually expose the container to you so that you can actually access. And I think you might be able to connect to the container instance itself. I'm pretty sure Google Cloud Functions also runs on containers as well, but the Lambda doesn't. Lambda runs on the micro VM technology, which AWS has open source called the Firecracker. It's the same kind of virtualization technology that is also underpins Fargate as well. And so so it doesn't run on containers, and which allows them to do some optimizations that just not possible. And it's also why when you think about the Lambda functions and cold start performance, there's been a lot of benchmarks in the past, and you'll find that the Lambda functions, the cold start would tend to be a lot better compared to Azure functions and Google Cloud Functions, because the Lambda service is able to do a lot of optimization that is just not possible if you're tied to open standards like Docker, and you have to rely on the existing container infrastructure. But ultimately, those micro VMs, Firecracker execution environments are still created on the bare metal instances.
Yeah, and it does make sense. I know, and I think you've put it perfectly. I mean, I gather that it doesn't really require a container, but as far as the compute side, you can do it with really any compute that makes sense. But the container is well suited for it. Certainly lightweight, especially since you're submitting code, and the container might be out there running, but I assume would have to be assigned to whatever code you're sending to be run.
Yeah, there's also other things like Cloudflare has got its workers. I don't know if they're still running on the V8 workers because there was some security, I think, issues that was raised by some researchers. I forgot the exact details, but I think it was something to do with the fact that they were using C groups, and someone was able to find a way to basically escape the C groups boundary, and so you're potentially able to access maybe memory or data that belongs to somebody else's functions. Yeah, exactly, and that's one of the reasons actually why Lambda. I guess it's not Lambda, but the AWS teams has created Firecracker so that they have a stronger isolation and in terms of that execution environment than just using C groups. And that's one of the security reasons why they created the Firecracker technology. But even then, as far as I know, they still don't do multi-tenancy. So if a bare metal instance is running your Lambda functions, then they won't allocate another customer's Lambda functions to the same bare metal instance. So I'm guessing it's just for precaution, so that even if they have confidence in the security isolation that you get with Firecracker,
it's the unknowns and the peace of mind.
Yeah, exactly. So just the peace of mind that they don't want someone else, something to happen, so that the potentially customers can break out and access somebody else's information.
That's interesting. I need to look more into Firecracker for sure. I was aware of it, but I have not done much research with it. So as you're talking here, it's dawned on me a bit that as we compare, again, I feel like we're going to compare serverless to containers throughout the rest of the discussion. So I guess it is what it is, and it helps me. But a container, a big allure of containers over virtual machines is that promised portability that we really didn't get to quite to maybe what we dreamed of, right? The whole drag and drop of a VM from one cloud to another, not really there in practice compared to what maybe a container can do. But a container is wrapped with libraries, runtime, all those things that need to execute that environment. And as you abstract this with serverless, it makes me think, do you lose some of that portability? And are you then, and I hate using the term, but are you a little bit more into a lock-in state with the platform because you are really reliant on what the platform, we talk a lot about Amazon, Google, Microsoft, you're kind of coding to what they choose and how they run it, right? Because you're not bringing your environment, you're only bringing your code. So is there a bit of lock-in? How does portability work with serverless per se?
Yeah, so Greg Hopp, who actually works for AWS, he did a really good talk at re:Invent this year. I forgot the session number, but I think it's called something like "Do Modern Cloud Lock You In?" So he did a really good talk, specifically around the lock-in, and I 100% agree with what he said. So basically, I guess two things. Firstly, you're never really truly locked in because you can always rewrite application. So what we're talking about really is the cost of moving or switching. So when you're talking about rather than the lock-in being a binary yes or no, when you think about a cost, you can think about in terms of degrees of how expensive that the switching cost really is. It's not. And when you think about technologies in terms of switching cost, it's not just going to be about the vendor itself. There's also the product. So you are, in the same way you have a switching cost to containers. You're using Docker. You're not using Rocket. So what if Docker goes away tomorrow, or they do something drastic in terms of changing the open source licensing? Maybe they start charging you like Terraform or something else. Does that mean that you now have to re-architect your container images so that you use a Rocket instead of Docker? And same goes to other tools that you may be using, within your containers environment. So there's also a switching cost involved in terms of the decision that you made to use containers. And same goes to potentially also switching costs involved with working with certain libraries and frameworks or programming languages. I've worked with companies in the past that couldn't have to spend years to try to move away from a .NET web framework that has been abandoned. But because they're written their code in such a way that all of the business logic is written into the request handler, so they spend a lot of time to rewrite a lot of the code base so that they can move away to a different web framework. So there's also switching costs involved with that as well. And not to forget, a lot of enterprises go through this cycle of every 3 years, let's rewrite everything in a different language. New CTO comes in, now let's do everything in Java. 3 years later, CTO goes, new guy comes in, okay, now .NET is the new thing. So there's also that.
Well, that's a good. So on that topic specifically, are there certain languages that lend themselves a little more agreeable to serverless? You got the new kids on the block like Python and Ruby, but you got the old school guys, Java, C#, and I'm sure there's perks of either, whether it's less code, more code, quicker execution time, but those seem kind of trivial unless you're building something at scale. But are there certain ones that have an upper hand when it comes to learning serverless?
Yes. Can I just let me finish the last question? So I get into the punchline. Firstly, you should kind of consider in terms of instead of lock-in being a binary thing, think about the switching costs instead. But also on the other side, that's a risk that everyone should be thinking about in terms of how likely do we make a switching decision later that's going to incur that cost, and how much effort it's going to take and how much cost it's going to cost us in terms of building that abstractions upfront so that we can guard against some of those costs that's going to come later. But then the other side of that, the risk is a reward, because there's no reward in life without taking some risk. Every time we put food in our mouth, there's a chance that we may get food poisoning, but doesn't mean that we stop eating, right? And so, when you are buying it into a cloud and working with your cloud partner and trying to get the most value from that relationship by using AWS for all the things that you can do for you, then you're also going to get maximum utility and value from that partnership. And with serverless technologies, you're really going really deep into the relationship and trusting the cloud and using the cloud for everything it has to offer, which means that you're going to get the maximum amount of value in return, so that you can go to market a lot faster. Everything is going to be a lot easier, potentially more scalable, cheaper, and more secure as a result. But of course, then you have to worry about, okay, what if we make a decision later to switch to a different cloud provider or switch our code from Lambda to containers? What are the different things we can do to kind of help us mitigate some of that cost later? And there are patterns you can use. Things like hexagonal architectures is a really good coding pattern for you to write your code in such a way that you can easily your domain logic is encapsulated away into some domain modules, so that you can easily migrate your code by just changing the adapter, so that instead of using the Lambda's event context directly, you will translate them to domain objects, and then that's going to you're going to use that to call your domain modules and libraries, so that you have that translation layer. And when you need to switch your code from running in Lambda to running in a container, you just change the adapter. So instead of working with Lambda's the event and context, now you're working with Express.js is a request object handler and response handler objects, and you have the adapter layer that translate things from the web framework you're using to the domain object that you're working with in your domain logic. So there are lots of different things you could do to help mitigate that switching cost. But of course, all of those means that you have to do more work upfront to help mitigate some of that cost. So it becomes a question of, okay, how likely are we going to do that? So how much effort should we put upfront to help mitigate that cost later? But yeah, it's something that you should be thinking about, but you should be thinking about in the right context and framing, as opposed to just, lock-in is bad, the lock-in is expensive, so we should never use native services. So to your other question about which languages is going to work better with Lambda, it really depends on what it is you're trying to do. The main impact the language is going to have on your Lambda functions performance is cold start. And with Java and .NET, because of the fact that you got this virtual machine that needs to be sort of bootstrapped and initialized at runtime, and that takes a lot more time. And with the Lambda, you've got this lots of really small independent execution environments for your application, which means that initialization has to happen every single time the new environment is created, which is very frequently, or can be very frequently. Then so you're more likely to see cold starts that are in the order of several seconds compared to maybe a few hundred milliseconds for, say, a Node.js function, or for a function written in the Rust or Golang, which is compiled to native. So for that, AWS has done a lot of work in the recent years to help improve things. So for one, you have the provision concurrency, which is a mechanism for you to say, you know what, I'm happy to, instead of just having on-demand execution environments gets created when a user request comes in. I'm happy to pay a certain amount of money to AWS, so that they will keep a certain number of those execution environments around all the time. So to serve my baseline traffic, essentially I'll never see cold starts, and so my user's experience is preserved until when there's like a sudden unexpected spike in traffic. So you can do that, but then for Java and specifically, there's also a new feature, relatively new. It was announced in the reInvent 2022, called the Snap Start, which is a way for you to say, okay, AWS it only works for Java, but what AWS is going to do in that case is when you deploy a code change to your Lambda function, what it's going to do is, as part of the deployment process, it's going to create a new execution environment, and it's going to then load, pull up the JVM. It's going to the class loader is going to run and load all a lot of your classes, except for anything that you're doing with a reflection and things like that at runtime. But then it's going to then take take a snapshot of the memory and the disk space so that it's going to cache those. And so that means that when the request actually comes and the Lambda functions is going to create a new execution environment on demand, it's going to, instead of booting up the JVM from scratch, it's going to load the memory snapshot instead and the disk snapshot so that you've got something that can boot up a lot faster because most of the work has been done ahead of time and there's been saved into this snapshot. So certain things won't work. Things like random, you have to do special handling for random and any, I guess a lot of the cryptographic libraries that requires like a seed of value that gets initialized when the class loader runs. So things like that you have to pay attention to. But otherwise, you can, I've seen people report the cold start time for Java functions going from a few seconds to a few hundred milliseconds. So it can make a big difference in terms of the performance of Java functions, which is important when you have user-facing Lambda functions, typically, APIs that are used by the front end. So if you have a cold start that's a few seconds, that means the user is going to, even if it's just 1% of the time, that means 1% of the request user makes is going to take a few seconds to respond, and so it's not going to be very good for user experience. But if you're able to make your cold starts fast enough so that even when they do happen, it's not a big impact on your user experience, then the happy days. There's also the ability to use a Grill VM for Java or a .NET Native for .NET applications, so that there are other solutions that are perhaps more heavyweight because there's a lot more work development team have to do rather than just switching on this setting. You have to compile your application in a certain way to compile them to native. But again, if you're doing user-facing API stuff, that's something that you really have to think about when you're using Java and .NET. But if you're just doing background data processing, who cares if there's like a 5-second cold start occasionally, because that's all happening in the background anyway. So no user is actually waiting for that. And so those are some of the things you have to think about in terms of choosing the language. Mostly it's around the cold start and potentially memory use. So mostly, mostly the most important thing to think about is the cold start performance for your language.
So outside of public cloud environments, are there opportunities to sort of test and run containers in, say, a premises cloud or software solution sets?
So there are a few frameworks out there, things like IBM OpenWhisk, and there's also Kubernetes and a few other frameworks that allows you to essentially give your developers the same program, or so you can event-based program model that the Lambda and other functions of service things that gives you by running them on top of your existing Kubernetes cluster. So if for an on-premises environment where you've got Kubernetes going and you've got this containers environment and you've got developers that really likes the programming model and deployment model that the Lambda gives you, and the ability to trigger your function to trigger your code to run without having to run these containers 24/7. You can use things like OpenWhisk and Kubernetes, and there's quite a few other ones like that, so that you can actually bring those similar developer experience to your own on-premises setup. But that is just mostly about mirroring mimicking the developer experience and deployment experience, but you still have to, at least somebody in your organization is still going to be responsible for the runtime behavior of the system in terms of, it's all well and good being able to, create this container environment to run your function for every request, but then, you're still running on, machines, so that, you start to think about, how to efficiently allocate those machines to the right, those containers to the right underlying machines. And then when you run out of space on your physical machines, what do you do at that point? You don't have the same, I don't want to say limitless, but a very deep, a huge amount of compute resources that, say, a public cloud can offer you. So and also when something goes wrong and machines need to be replaced, or there's networking issues and things like that. Also security. Now your someone in your organization is still going to be responsible for maintaining and securing and managing the underlying infrastructure for your on-premises environment. So yes, you can kind of mimic that developer experience on premises, but you are still responsible for the runtime behavior and security and everything else.
Yeah, I mean, the parallels to like containers is interesting. So, and maybe this isn't a good example here, but look at Amazon and Microsoft. Both of them had their own container services, ECS on Amazon, and then was Microsoft's ACI, Azure Container Instance. But once Kubernetes rose to a level of adoption, they both released their Kubernetes services. Do you see a level of standards happening to serverless that like maybe the big three, like Google, Amazon, and Microsoft, agree to in the serverless that will help some of the portability here? Or is it still too early to tell?
Probably too early to tell, and I also don't think that is likely to happen. And I mean, certainly, if I was someone from the Lambda team, I would think that we've got the reason why we're able to offer our customers the level of performance and experience and developer experience is because we're able to customize the execution environment, because we can do things that we wouldn't be able to do if we were to use containers. There may be spaces where you can form some standardization, specifically around invocation event payloads sort of structure. So there's been like a move for things like something called the cloud event, which is kind of still try to push towards that, some kind of a standards around the invocation event itself, which even within AWS is just all over the place. Depending on what triggers a Lambda function, the payload shape is going to look something different. But in terms of the actual platform itself, I don't know. I struggle to see why someone like AWS would do that when that's kind of the opposite of what their customer is asking for. The customer is asking for better performance, better scalability, faster code starts and everything else. And so instead of trying to meet some standards and potentially giving your customers a worse experience, I think at least I want AWS to just do their own thing and try to optimize their platform in any way possible.
That's a great answer. It helps clear it up for me in the sense that why hasn't it happened yet? But that's it makes a lot of sense. So you mentioned cost a couple of times in there in a couple of these responses, and it did make me want to ask about how one goes about estimating the cost of a potential deployment. Because if it's anything like trying to spec DNS usage and how many millions of requests you're going to see, or S3 transactions, how many puts or gets are you going to have? Like it's kind of a tough thing to estimate. And it seems like this is really how you're estimating the cost. I'm sure there's still some perpetual things running, or arguably perpetual in the background. You might have a database of some sort, some storage out there. But when it comes to planning costs around serverless, what are some of the best practices and how you do that? Like, I'm sure there's plenty of lessons learned in your experiences on how you estimate cost. But what advice can you give?
Sure. And I guess before I answer, can I switch the question back to you and say, how would you estimate the cost for a containerized application?
Oh, I would say it's outside of the steady state. So there's the containers. I would guess that most would have at least a floor. There's something sitting there running, and then there's this whole scaling mechanism. So I see where you're going, that I've got my floor, just the running environment. And then as I scale, here's how I'm going to, here's my points at which I'm going to scale, whether it's CPU or memory or request driven, what have you. And I'm going to put a cost associated with that. As I scale to X number of users or requests, here's how much that's going to cost. And with functions, I guess I don't know how much of that, I assume a lot of that's still relevant, but you also don't really have to have much underlying running, right? It's because, as you said, you pay for the code when it's executed and really only then. And so are you just really good about knowing how long every piece of code is going to take to run? And is that really that important, like whether it takes a second to run or 5 seconds to run?
The execution duration is important, but probably the most important calculation or going how you go from A to B is still the same way you talk about. You talk about how many containers I need to run for a given number of users. The given number of users is a proxy to the actually important thing, which is how many requests per second you're going to handle. And then from there you work out how many, based on some testing you've done, how many requests per second can we handle with one instance of my container, and that's how you then work out, okay, what's the baseline number of containers we need to run, and then as you scale and look at, okay, what if the number of users in a daily peak would be say 10,000 concurrent users, and so with the number of requests, how many requests per second do we expect from that number, that many users, and what does that translate to the number of containers we need to run based on our understanding of how many requests per second we can handle with a single instance of our container. So that's kind of how you predict your container cost. You can still do the same thing with your serverless environment. In fact, it can be much more precise because you know exactly how much a single request to API gateway is going to cost you. Excuse me. And you also from some testing, you probably can figure out how much time it's going to take your Lambda function to execute and to handle one single user request. And so from there, you can work out, okay, what's the cost per transaction. So imagine a really simple API function that involves the API gateway, calling a Lambda function, putting something into DynamoDB. So every single hop a component in that user transaction is pay per request. And so you can, with some estimate, some heuristics, maybe some testing, you can probably work out a reasonable average for the execution time for a Lambda function. And given your memory allocation, you can work out how much that single invocation is going to cost you. And then go from the same number that you're using to estimate the cost of your container environment. How many requests per second do we expect to see at the peak, and based on the number of users we expect to see and the kind of level of activity we expect to see from those users. And so you can work out, okay, given the fact that at 10,000 users, 10,000 concurrent users, we're expecting to see maybe about like a 1:100 ratio, so about 100 requests per second, and so every single user request involves the API gateway call, Lambda function invocation, and a DynamoDB write put operation, and so that's some $0.125 per user transaction multiplied by 100 requests per second, give you some number, multiply that by number of seconds, and then hours, and then you go from there to work out what's the likely or estimate cost for your application. And then you start looking into your entire application and see, okay, all right, so we're not just using Lambda functions and API gateway and DynamoDB, and from there we also have to trigger something else, do some event processing, and so there's also going to be some calculation based on flow rates because say we are using SQS, we're writing a bunch of records into SQS, and we are using SQS to invoke a Lambda function in batches of 10, and so again go from there. Okay, how much is those 100 requests per second to SQS going to cost us, because we know how much a single request is going to cost us from for SQS, because again it's based on per request. So based on the initial input of number of users you expect to see and the number of requests you expect from those users, you can start to look at your architecture almost like, okay, every single hop in my architecture, I can start to put a number on that. And there are also tools like Cloud Zero that allows you to turn this estimate into more sort of like a real-time monitoring, so that you can see, for individual components, how much cost you are incurring based on the request that you're actually handling. But in terms of just doing the estimate, it's just starting from the initial number, what's the input rate, and then go from there and start looking at your architecture, just on one component at a time, and then start putting a number on that.
Yeah, it's funny. As you're talking about that, I'm thinking, okay, this is a really long math problem starting from like the user request to the end of the request. But I'm like, man, you can actually probably put a price against an actual request. That's pretty interesting.
And that's what we actually talk about when we talk about the FinDev, which because we've this which is quite a popular topic within the sort of serverless community, because with this pay-per-use pricing model, you can now really fairly provided that you have a good understanding of your user behavior and traffic pattern, you can very accurately estimate the cost for individual components and the functions and so on. So when it comes to optimizing, before I've done many optimizations on my server EC2 applications or container applications. Oftentimes it's just, okay, I've got a theory that this may do something, and then I just go ahead and do it and then see what actually happens, because I can't easily attribute the cost of running those containers of EC2 instances to specific user transactions and specific workloads that we're running, because everything kind of blended together into one number, which is okay, what's the cost per hour that we're paying for these servers. And so we come with things like serverless and the ability to look at every single component and understand the cost of that component. You can now start to put the cost for, say, supporting a feature. And I actually know this guy Goiko, who wrote the book Specification by Example. Is one of my favorite books on testing. And he had this thing where he's built a startup, and one of the things he did was he had this idea for a new feature which he thinks people is gonna like. His co-founder was like, no one's gonna want that, and he didn't believe it. He went ahead and built it anyway, and he was able to see, okay, right. Actually, not many people used it, but he's able to put a number on that user transaction that are related to that feature that he's just implemented, so he can see the cost for that feature. And then he can also then work out, okay, how much revenue are we bringing in with this new feature? And he can actually work out, okay, you know what, we're actually losing money on this feature. So he eventually just decided to just cut the feature altogether. And when you can understand the cost of your system to that level of granularity, it opens up some really interesting possibilities in terms of optimization. When I want to talk about the optimization, okay, which function do I optimize? Well, if I look at a function, I see that it's costing us 10 cents a month. There's no possible reason for me to waste any time to optimize it. But if I see the function and it's costing us $1,000 a month, then okay, maybe it's worth spending a few days of engineering time and take that down to, say, half. Then the amount of time that I'm spending to fix it, so to optimize this, is going to pay itself back within, say, the next 4 or 5 months or whatever. So you can now start to look at every single optimization you're doing as an exercise that has got a return on investment, which is very clear to see when you can really precisely predict the cost and the return on those investments that you're going to put in to improve that cost for that component.
Let me ask you this. So serverless, if you're paying by, let's say, the second to run code, is there a point with which that sort of luxury of being able to pay at that level is overridden by bringing, I won't say repatriation, but like, at some point, does it get to a level where it makes sense to actually have a persistent container running if you were otherwise running that code for, let's say, an hour at a time? Or does it still make sense to continue writing it and running it in serverless? Maybe, I don't know if there's any sort of thing where savings plans or reservations apply to draw down on commitments, but at any point, does it make sense to move back to a container for running workloads or not?
Absolutely. My rule of thumb is that once you hit anything close to about 1,000 requests per second, say for like an API, that workload is going to work out a lot cheaper running on containers as opposed to running in with API Gateway and Lambda and whatnot. So the actual approach that most of us advocate for is the serverless first mindset, whereby you start with serverless. That's going to give you the faster time to market and the cost efficiency as you're starting out. So with that example example with Goico I talked about earlier, where you're building a new product or building something that you don't know if anyone's going to adopt. So you go for something that's going to be cheap and scalable. And so, you don't pay for it if no one's using it, but if lots of people are using it, you can still handle the scale, and hopefully your cost and your profit is going to grow with that usage as well, so that eventually things are going to cover for itself. And once you have a more stable environment that is running at a fairly high throughput consistently because you found market fit, which is congratulations. At that point, you can then optimize for cost, because every single request you're paying for Lambda and API Gateway, you're getting a lot of good things out of in return, but you're also paying a premium for that. And so when that premium starts to accumulate over, say, a consistently high number of requests per second, then you're going to look at potentially saving a lot of money by moving that workload back to containers. And if you look at those article from the Prime Video team, which talked about that, how they build something which they don't know if anyone's going to use. They use the step functions and Lambda functions to do a lot of the orchestration. And then like a year later, they actually surprised themselves, and they found that their service got a lot of traction internally, so they decided to optimize for cost and move their workload into containers, and they're able to save the cost by something like 90%. And so when you've got when you've got really consistent throughput, you can potentially save a lot of money by moving stuff back into a containerized environment where you're paying for uptime. And the rule of thumb you have that I have in AWS is that any service that charges you based on uptime is going to be about 10%. Well, it's going to be like 10x cheaper at scale. The important thing there really is look at your organization and understand what skill sets you have and whether or not you have the skill set available to run a scalable, large containerized environment already. Because that may decide at which point it becomes more expensive and or more cost efficient for you to actually run that workload on containers. Because you can't just look at your AWS bill and decide make all of your decisions based on that. You have to think about the total cost of ownership. If a workload is now costing you $100 a month on running on Lambda and API Gateway and all of that, and you think I can run this for $50 a month instead on just running on two container images on two containers on two different AZs, then you probably miss the fact that you're going to get that you may not have the right expertise in the company to work with containerized environment. And so you need to bring someone into the company to do that. Suddenly you're looking at, I don't know, what's a reasonable number for DevOps engineers in the US these days, but probably a few $1,000s a month. So suddenly, you are down a few $1,000s a month because you didn't have the right skill set in the company. And now you need to have that skill set in the company to operate your new containerized environment. And so you've got to think about total cost of ownership, which is going to be very different for a large company that's got lots of internal expertise with containers versus a team that's more sort of front-end focused and don't maybe necessarily have the right expertise in the company to help them run a large-scale container environment. So think about total cost of ownership and but at some point, yes, it's going to be cheaper to move your workload to containers. If you also, another thing to think about is that the opportunity cost, because if your team is going to have to spend more time just looking after the infrastructure, then that means that they're going to spend less time innovating and iterating on the product. So it's not just simply simple case of if it's cheaper by AWS build, then I should do this because there's also other costs involved that are less easily measured.
So last few minutes here, and I was going to ask a different question, but I think that the timing wise with your response there, it's super interesting. So labor market affecting everybody right now. Education is often trailing these rapid advances in technology. You're right. Containers, we're seeing more and more folks who are coming equipped to handle and administer containers. Where do you see this in the serverless market? Are developers being exposed early on to this type of development architecture, to like infrastructure as code and coding to serverless, where they're, in the AWS world, whether they're also using step functions and basically other services to pull this all together? or is this still something that you're learning on the job as you enter the professional market?
Are you talking about the formula like a new graduate perspective, someone who's just fresh out of university?
Yeah, I'm curious, at what point is somebody really getting exposed to serverless? Because obviously most of us who go through a computer background have programming abilities. We learn that. But to say that we are programming to an architecture like serverless and all the things that it takes to bring this together, it just strikes me as something that I guess I wouldn't know if it was something being taught or learned early on, or if it's something that you arrive at in your whether job or career you've gone down.
Yeah, I don't think I don't know of any university that has that includes actually maybe Imperial College in the UK, because I've done some talks with the students there, and they seem to have some exposure to the cloud and serverless technologies. But the good news is that learning serverless and learning the cloud is actually not as hard as it used to be. And certainly when you're working with serverless, there's probably only about 10 services you need to know reasonably well to be able to build most applications. And those services, once you've learned them, they're also fairly reusable. The knowledge that you get are fairly reusable. It's certainly, I think it's something that you can get to a competent degree fairly quickly. And I've got some training courses and I've got workshops that help teach people and how to get them faster as well. But yeah, there's nothing really beats just learning by it doesn't have to be on a job. It's just learning by doing. Pretty much all of us kind of did that, just learn by doing. And so when you've got something that you want to try out, is the nice thing with using serverless technologies is that you only pay when someone uses it. So when you're building like a hobby application and using Lambda, chances are you're never going to pay anything, because you're never going to hit anything go over the free tier. So it's much better to much easier to try those hobby projects and try things out for yourself and learn the technology really well without spending a lot of money on paying for EC2 instances that you forgot to turn off, and suddenly you see a $100 bill in your AWS account.
Yeah, no kidding. That's pretty. That's a nicety here, right? If it's not sitting there running idle. And I think we'll go. I'm sure we'll include some notes on some of those resources you talked about. I know you've got a website and a lot of tutorials, which are fantastic, and they're always up to date with the latest and greatest things that are coming out. So, Yan, thank you. I'm sure we got to half of the content that we had hoped to. Maybe we'll have a part 2 to cover all the other fun stuff. But I want to thank you for joining us for this edition of Cloud Currents, and I look forward to a follow-up conversation in the future, okay?
Thank you, David. Thanks again for having me.
All right. We'll see you. Thank you, Yan.